My name is Ming. I am a neurologist and a scientist seeing patients and running a lab researching on aging and neurodegenerative diseases. I also direct an anti-aging center at UCLA. As a Nobel Family Innovation Fund awardee, I'm very excited to tell you our work on reverse aging to delay diseases. This is a team project with doctors Bruce Hay, Robert Demerceau, and John Vonnegut. I can't advance my slides somehow. Okay, that's fine. As a physician, I'm acutely aware of a problem in the medical field that a group of diseases known as disease of aging account for almost 70% of death in the US. These include heart disease, cancer, stroke, Alzheimer's, and diabetes. Among all these diseases, aging is the strongest risk factor. Take AD, Alzheimer's disease, for example. Numerous studies suggest that up to 50% of us over the age of 85 may get the disease. The prevalence of Alzheimer's disease doubles every 5 years. Therefore, if we can stop aging by 5 years, our society will cut the disease burden by half. So there are two strategies to think about how to combat these age-related diseases. One strategy is to work on individual diseases. Another is to delay aging itself. So our goal is to pull down this aging curve. The x-axis is the time, the y-axis is the incidence of these age-related disease. If we could pull down the age curve to cut the disease incidence, such as neurodegeneration, heart disease, cancer, diabetes, frailty, and compromised immune system, we would significantly improve our health. A key site at which cellular aging occurs is the mitochondria, the powerhouse of the cell. They contain their own DNA, abbreviated here as mtDNA, and the accumulation of damaged DNA lead to cellular dysfunction and death, and ultimately aging. So on the right-hand side, left side is a schematic, and on the right-hand side is the real cell with numerous mitochondria and mtDNA. So during our lifespan, the deleterious mtDNA accumulates throughout life. And when the deleterious mtDNA reach a threshold level in the cell would dysfunction and die. So as you can see here, that the damaged mtDNA leads to pathology in the muscle, heart, brain, and pancreas. What we want to do is to remove these damaged DNA to bring about, to reverse aging. The challenge of the field is due to lack of tools. In collaboration with Bruce Hay's lab at Caltech, we generated the first Drosophila transgenic heteroplasmy model in post-mitotic tissues, which are muscle and neuron. This provided us a proof of principle to demonstrate that we can actually remove damaged mtDNA by manipulating existing pathways. So here's how we generated that. We generated a mitochondria targeted restriction enzyme plus ligase. This allows us to create mtDNA deletion. Using this tool, so as mitochondrial DNA and circular, here are a wild type DNA illustrated by blue. We generated a mixture of damaged DNA, which is illustrated here as red, as well as the existing wild type DNA. Our goal is to manipulate genetics, genome, as well as selective of compounds to selectively remove these damaged DNA. So the team is composed of me as a neurologist and pharmacologist and director of Anti-Aging Center. Bruce Hay is a key collaborator at Caltech. Robert Demisile directs molecular screening facility at UCLA, and John Vonnegut is a geriatrician working on human muscle aging related to mtDNA mutations. So our goal of this project is to generate analogous human culture systems that carries mtDNA deletions. Second goal is to use this tool to carry out genome-wide screens and compound screens with these cultured systems. The goal is to identify factors that can remove cellular signature of aging. What I want to tell you that in addition to aging implications, these compounds can also help a disease called Mitochondria Disease, as mtDNA mutations also leads to this group of disease, which collectively affecting 1 out of 5,000 children. These compounds will have potential to serve as therapeutics for these children. These children would have cognitive disability, strokes, seizures, hearing and vision impairment, muscle weakness, and diabetes. Finally, I want you to imagine a world in the future where we can improve our health span as well as this lifespan. We will try to rectangularization of this life curve so that we can live a healthy life and die with less suffering and pain. This is my dream and our goal. That's the end.